This is example 10.6 from Discovering Design with Chemistry. A mixture of gases includes 15 moles of chlorine, 12 moles of argon, and 11 moles of oxygen. What is the mole fraction of each gas? And what they're asking is really just, A just kind of represents whatever we're talking about. So the moles of component A over the total moles in the whole mixture. So if this is a mixture of gases, we have three things. We have chlorine, we have argon, and we have oxygen. If we put the amounts each of those has together, we can see what the total moles are. So 15 plus 12 plus 11. These are all to the 10th place in precision, so our answer will also be to the 10th place. 15 and 12 is 27, plus another 11 is 38. So we have 38.0 moles. And then A means that just represents whichever one we're caring about. So first we care about chlorine. So if chlorine has 15 moles, and we're going to divide that by the total, so 38 moles. And then argon has 12 moles. And again, we're just going to divide that by the total. I'm setting these up and I will solve them in a second. And then our last one, oxygen, has 11 moles. And we have to keep our 0.0 with each of these because it will matter when we divide. And again, we divide it by the total. So the moles cancel out, and what we're left with is basically sort of a fraction of the, what portion of this gas is chlorine, what portion of this gas is argon, what portion of this gas is oxygen. So 15 divided by 38. We can only keep three significant digits, so that'll be 0.395. And that would be, the way we would say that is X of chlorine equals 0.395. All right, and then our next one is 12, so 12 over 38. Again, we have three significant digits, so we're going to only keep three significant digits, so that's 0.316. And we would write that as X of, you can also write the whole word like that. You can write argon too. 0.316. And then our last one is oxygen. And same thing. We just divide 11 by the total moles of all of them. We keep three significant digits, so 0.289. So X, I'm going to abbreviate with my little O here again. 0.289. So that's our mole fraction for each. And if we add these together, we should get something pretty close to 1. So let's do this. So 0.395 plus 0.316 plus 0.289. And it equals 1. So, and it could be that it might be slightly off because of the way we rounded with the significant figure. There's always an error in that last significant figure. So if we round, we might get like 0.998 or 1.002. Those are examples from the book, but anywhere that's pretty close to 1 is still 1 because these are just fractions of a whole. And it's a mole fraction because we're counting the number of moles in the part divided by the moles in the total mixture. All right, so there's your answer for that.